So this is a quick demonstration of the serialization system, or the save management system within the Red Stair. I'm going to be showing you first the system itself from a high level point of view, and then I'm going to show you how it's actually implemented. So for this example, I'm going to get rid of all of the folders that are previously made. So we're going to get rid of the save data, and we're going to get rid of the saved pictures folder. This is a custom folder that is generated at runtime. Basically, within the Red Stair, you have a camera, and that camera takes dynamic textures and applies that to the camera picture. So as you can see here, the player can pick up the camera over here, they can take a picture, and that picture holds a whatever the player was pointing the camera at, right? And so this is a dynamic material that is applied to each picture, as you can see. So if we go over here, this is applied to each camera. So you have a base material slot, and you have another slot that is a dynamic material instance, which gets updated at runtime, which you can see over here. And it creates a static texture or material on it, and that never changes. Now, because the Red Stair is a VR game, and some of the assignments can take a relatively long time, along with the fact that sometimes the player can only take pictures of a specific individual once, saving these pictures is really important for not only us, but for the player as well. Basically, what I wanted to achieve with this system is so that the materials that are created at runtime are stored onto the disk, which are then, when the player quits the application and then 5 days later continues playing the game, the pictures and their materials are exactly the same. So that helps with regards to figuring out, hey, maybe the player needs to take a picture that they've use a picture that they've taken in assignment 1, and they cannot get otherwise. Basically, keeping track of their pictures. This is all done in the game mode, which is called GMVR. There are some. This is basically in the entire code. If there is, this is how a save is created. If there's no save, then it's going to create one, and it's going to create one using the string name and the Steam ID value, which we'll go over in a minute. And then it's going to, every single time the player exits the game, it's going to store a number of things. So first thing that we want to store, obviously, is the picture transform. What is the current transform of every picture that currently exists in the world? What is their evidence? What if the player takes a picture of a certain person, that character has specific data attached to it, and so that needs to be parsed to the camera picture, which needs to be able to do that, use it for the facts, so the player or the game knows whether or not an assignment has been completed or not, or if it's the right evidence to begin with. The picture text, which is basically the text that appears underneath the picture, and then here are some safety conditions of, hey, what are the current assignments actually doing. So also storing the current assignment for each scenario, rather. And we have 2 in the game. We have one that Luke has been working on, and one that Raymond has been working on. So we also need to store that, so that if the player quits the game after 50 minutes, they can resume with the assignment that they left on. Then it's going to store a bunch of things into these arrays over here. So for each picture that exists, it's going to get their all these all this data, and it's going to parse that into an array, so we can then use that on the moment the new save is loaded. These are the nodes that I created for saving the pictures to from a render texture to a serializable texture. So basically, from the render texture on the camera to a static texture that you've seen just before. It's going to be the picture, or the image that is actually on the picture in the material slot. And then this is a function for storing that on the disk, and it has a bunch of conditions to to check what's the, so for example, it's going to store that in this directory. It's going to store that under TRS camera picture underscore something, and then store that as a PNG, save the pixel array data, and then basically execute the function. So basically, as you might have noticed, there is now a saved picture folder in here, which wasn't there before. So I'm just going to delete these files again, and I'll show you how they are generated. Right, so I'm basically going to take a whole bunch of pictures, and you will see it update in the window over here. Let me maybe resize the window quickly over here. Yeah, you should be able to see that. Now, look carefully. I'm going to take a bunch of pictures, and it's going to store that the moment I quit the game. Take a picture of this thing, take a picture of the clock maybe, take a picture of the typewriter, the fan. Okay, I'm going to quit the application now. And there it goes. It generated a folder, a subfolder, and then the scenario 1, and as you can see, it stored all of these pictures onto the disk. So right now you can see over here I can basically access these from the disk itself, right? I just click on it, I can view it, I can do whatever I want with these. They're stored as a 512 by 512 picture, because that is what the render texture resolution is. But that's here. Right. Now, if I go ahead and play the game again, you're going to see that, hey, the picture that I've taken is actually still also in here. So you see the exact same picture that I see over here, which is camera 8, corresponds with, well, if you count from 0 to 1, number 7 corresponds with picture number 8 in the thing that has been added to the array and then applied to the camera. And you can see that for all of these. So you have right over here, you have the circle one, which is number 4, corresponds with 3 in the array. The clock one, well, maybe a better one, the clock one, which is 5, corresponds with 6. As you can see over here, they're all the same, right? And then also, just to show you the actual thing, I'm also storing the data and answers struct over here. So, for example, this was a picture of Elise, the character over here. If we go over here to the evidence struct array, you see that all of the information over here has been parsed. So if I were to use this picture for to fax that back to the into the fax machine, that would work, right? This would totally work. And I can even show you that this works at even with quitting the application and quitting the application and then restoring and starting it back up. But for the sake of the video, I won't do that. But it works that way as well. So there's no, this is not a memory thing, right? It's not stored in memory or anything like that. It's taking the pictures that have been written to the disk, and it's loading that into the game again. So now to a more general thing, I guess. You saw me generate these picture or these folders, and you might wonder, well, why is it called 0 and then scenario 1? Let me enlarge this. Scenario and then 0 and then scenario 1. Basically, that has to do with the thing over here. Because there are two assignments, or scenarios rather, the one that Raymond has been working on, and the one that Luke has been working on. At begin play, it's going to essentially look for what the scenario is. So it's going to, and we call these event managers. Raymond's level has event manager Raymond, and Luke's level has an event manager called event manager Luke. Right, so I'm looking over here for whether or not that is a scenario, which scenario has been found, and if it has found one, then it's going to store all of that stuff under a specific directory. Right, so here you're over here you're looking for, if it is scenario Luke or Raymond, it's going to set this int to 0. If it's Luke, it's 1. If it's none of them, it's 3, which is basically just a safety condition. The point being that this integer selects which one of these directories it needs to create. We're in Raymond's level right now, so it's going to create a scenario. It's going to store all of these pictures under scenario or under the folder scenario 1, right? And then here I'm defining the TRS camera picture, and save it as a PNG, and that is essentially the function. The reason why this is a 0 is because this is basically a way to order, if there are multiple people that play the game on the same PC or device, but place the game under a different Steam ID or user name. You don't want those to overlap, so basically it's going to get the Steam ID, and then under their Steam ID folder it's going to store these pictures, right? So what I could do is get, I don't know, this could be 2.5, something like this, right? It could be something like that. I can take pictures using that. This might work, I'm not entirely sure if it will. Yeah, so there you go, right? So I just changed the thing, the scenario, and it's going to store all of these pictures under that folder, right? And I can look at them and I can sort of go through them and see what's up, right? And so if I play again, it's going to store all those pictures again, right? Let me hook that up again. But this is basically a way for me to support multiple people with different usernames or Steam IDs to play the same game, but not overlap or overwrite their save data. And these are the nodes for getting the render texture or the texture width and height in the pixel array data, and storing all of that onto the disk. For loading these things, it's essentially the same thing, where you just get what their Steam ID is, you check which scenario it is, and then you're loading the textures from the file path, which is then, depending on what it is, it's going to be that. It gets all of that, and this is the most important part. So what it basically does is, you have a picture, And the picture has two material slots, and instead of saving these images for every single time the player has taken the picture, instead what it does is it creates the images that have been created by the camera. It is stored that as a dynamic material instance, and at the well, as you can see right over here somewhere. Yeah, right over here it gets the material slot, and then it's going to save all of that onto here. And then I've already said it's going to store all of these other things into an array and then load that on begin play if there is a thing or a save that has been found and created. For the cameras or the pictures themselves, we're not actually storing the pictures that have been taken, so the objects or the classes, actor classes themselves, but it's creating the we're basically spawning these camera pictures at begin play, and then for each of those we're setting like all of these things, right? So the picture text and the evidence struct and things of that nature. Now if we go to the let's see, texture, go to definition. This might take a little while. I should have started this ahead of time. Alright. Almost loaded. Still loading. Still loading. Still loading. Right. So this is basically the C++ code that handles all of the storing all of the pixel data, a render texture to a serializable texture, or texture 2D essentially. So basically what it's doing is there is an RT camera over here, and this is a render texture, which is a thing that is updated every single frame depending on how you implement it, but in this case the moment the player picks up the camera is when it updates, and the moment it has taken a picture it's creating a new render texture. It's creating a new render texture. So basically what we need to do is create this render texture that you see right over here, and store that as a 2D texture. And there's nothing in Unreal that natively supports this. So we need to do a bunch of C++ to actually do that. And this is essentially what you see here. The function calls and everything of that nature is basically, well actually it's over here, is this right here. Texture to serializable texture. This is what this is basically what mainly does this part, right? This is writing the picture to the actual or gathering the data and storing that as a serializable texture or the 2D texture, and then this function actually saves all of that to the disk and the right file path and such. Now I had to refactor a bunch of this to make it work with our current implementation, because obviously, okay, so the base was made by a programmer that worked on this sort of in block B, but we haven't, up until like the very end of block D, we hadn't really interacted with this code, and obviously it wasn't working, so I had to redo a lot of that. But storing these images or these materials was definitely the hardest part of this. And then the rest is sort of, okay, how do you figure out how do you actually store, how do you structure how these images are stored on the disk, because obviously there needs to be some form of logic there. So, you know, storing the picture under save pictures, and then under scenario 1, and then all this stuff. Now also what this does is, these pictures, because we're using the Steam Cloud, the moment the player quits the application is the moment where all of these textures are also pushed to the Steam Cloud. So these textures, the moment the player quits playing the game, it's going to push all of these textures to the Steam Cloud, so that if so it's always there as a backup, right? The only problem with the system at the moment is that it doesn't, there's no way for us to really encrypt this. So what the player could essentially do is go into the saved folder, which will probably actually be in the app data at that point, in the package files. But they could go over here to scenario 1, and then delete these pictures, and then like I'm doing right here, save pictures over here, deleting these, and then if you play the game again, they will just be blank, right? So that is a possibility, that is still a thing with this system, but there's not really a way to encrypt that unless we do something with the source code, or we encrypt this in like a very weird way that it is not possible. But the thing with the main thing with that is, we already have to like allocate persistent files to the user's disk, which is already sort of a thing, and then to actually also encrypt that would be sort of, if we have more time we might be able to do it, but for now, yeah, just don't delete these files.